All right, this is 9-7, solving a system of equations. I just want to remind you, we've actually already done this lesson, but we did it back when we were covering just lines, way back at the beginning. And so just as I want to recall how to do this. So first here, we had a red line, negative x plus 4, this line right here. So if we graph this, it's going to look like this. We'll graph that line. Graph the purple line. And notice the point of intersection is right there. So we found the point negative 1, 5. Right? So we did that back already, again, at the beginning of the year. And I also want to remind you that we did that by graphing, but we also did it by substitution, and we did it by elimination. So let me remind you how to do it both of those ways. So let's do substitution first. So substitution means I'm going to literally substitute one equation into the other equation. So literally this has y, all of that is what y equals, and I'm going to substitute it into the other equation. So negative x plus 4 equals negative 2x plus 3. And then I just solve for x. So I'm going to add 2x to both sides, minus 4. So I'm going to get x equals negative 1. And then if I substitute negative 1 back into either equation, it does not make a difference, I'm going to get 5. So negative 1, 5, again, I found it by graphing, and I found it by substitution. Now, the third method that we did it by elimination. So just want to remind you how to do elimination as well. We typically put these in standard form. So x plus y on the left side, and this one right here as well. And then what we did was we want to eliminate one of those variables. So if we subtract those two equations, we're going to get negative x. The y's will eliminate equals 1 if we subtract the equations. And then divide both sides by negative 1, and notice I get x equals negative 1. The same thing what I got there. So you can use elimination, substitution, or graphing. So again, we've already done that lesson with lines. So I want to remind you as we're getting toward the end, we've covered 3 types of functions. We've covered linear functions, which again, y equals mx plus b, and it makes a line. So if you look at the graph, it makes a line. We've also talked about exponential functions, and this is when the exponent is the x. And again, if you remember growth functions, which is what I have graphed there, and there's also decay functions. Again, if you're talking about population or bacteria, something could grow really fast or decay really fast, like the value of a car or something like that. So those are exponential functions. And then quadratic. Quadratic is what we've been talking about recently. It makes the shape of a parabola, and it's symmetrical, and the exponent is a 2. So we've talked about linear functions, exponential functions, and quadratic functions. And so when we graph any one of these types of systems here, what we're going to do is try to find out what's in common with them. Well, notice what I've done. I've graphed a parabola. That's a quadratic function. And notice I've graphed a linear function. I've graphed, again, I can use any of those types of 3 functions that we've talked about so far. And then I want to find the points of intersection. So in this case, I have 2 points of intersection, negative 7, negative 2. And then I also have 2, 4. Those are my 2 points. So there are 2 solutions to this scenario. Now there's also, it's possible when you graph a parabola, so let's graph a parabola, and let's graph a line, it's possible that it only hits at one spot. So there would only be one solution. And it's also possible when I graph a parabola and I graph a line that they may not intersect at all. So there are no solutions. So there's three possible scenarios where they intersect at 2 spots, they intersect at 1 spot, and they don't intersect at all. So let's look at our very first scenario here. So here I have, just by looking at the blue, I have a quadratic because I have, notice the exponent is a 2. So that's going to be a parabola. And then I have a line because of, I notice the exponent is a 1, so that's y equals mx plus b. So let's go ahead and graph them, and then we're going to go ahead and solve it by substitution. We're not going to use elimination because we're primarily interested on this lesson using graphing and substitution, although you could use elimination as well. So let's just focus on these two methods. So let's go ahead and graph the parabola. So I graphed a parabola, and now I'm going to look at y equals mx plus b. And so this I'm going to actually show just because it's just a reminder how to do the slope. So up 2 over 1. You start at the y-intercept at -4, and then the slope is 2. So up 2 over 1, up 2 over 1. And notice I see my 2 points of intersection right there and right there. So I have 2, 0, and I have 6, 8. Those are my 2 points of intersection. Now let's solve it by substitution. One, it's just another method to solve it. It's also double checking to do it just a totally different method. So substitution means you're going to substitute one equation into the other equation. So all of that I have circled, all of this is what y equals, and so you're going to substitute it into what the y equals. So x squared minus 6x plus 8, and that equals 2x minus 4. And then you're just going to solve. Remember, it's a quadratic. All right, so to solve quadratics, you typically want to get everything equal to 0. So we're going to bring everything over to one side, and we have it equal to 0. And to solve quadratics, again, I would recommend trying to factor it. You can also use the quadratic formula or completing the square, but typically factoring would be a little bit quicker. So here you have x minus 6 equals 0, and here x minus 2 equals 0. So x equals 6, and x equals 2. All right, so if we substituted those back in, you could substitute it into the blue equation or the red equation, and the red one is obviously an easier equation. So if I substituted 6 into right here, 6 times 2 is 12, 12 minus 4 is 8. So I have 6, 8, which again, is what I got when I graph. And if I substituted 2 in, again, I'm substituting into the red equation. So substitute 2 in, 2 times 2 is 4, 4 minus 4 is 0. So I have 2, 0 as well. So again, I got the same answers using substitution as I did graphing. So I know those are my 2 points of intersection. So let's look at another example. So again, same scenario, let's go ahead and graph the parabola, and then we're going to graph the line. So in this case, it's the same type of functions. We're going to find the point or points of intersection. All right, I graphed the parabola, and then let's graph the line. So we're going to start at +3, and we're going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Now, if we graph this, it's going to be very close to this line, to the parabola. Now, you have to look at it carefully. According to my graph, it looks like it intersects in 2 spots, but it actually doesn't. It only intersects right there at 1 spot. And again, you'd have to look at it on the calculator or zoom in and look at it. But 2, -1, this point right here where it looks like it isn't common, that is not a point of intersection. Okay, this point right here is not a point of intersection. So, but 1, 1 is. And again, if you're not 100% sure, you can substitute 1, 1 in and see it works. But let's also go ahead and solve it by substitution, and you'll see what I'm talking about. So again, I'm going to set this equation. I'm going to set it right there. And then go ahead and solve. Again, quadratics, you want to set them equal to 0. So notice here, if I factor this, I get x minus 1 you're going to get the same thing there. So we can see that there's only one answer on this. And so when I substitute 1 back into the equation, I get 1. So 1, 1 is the only solution for that equation, for those system of equations. I also wanted to just to quickly remind you, another option you can use it as a double checking method, as a triple checking method, is if you use your calculator, I mean, you can push graph if you want. It looks the same as my graph. The other thing you could do is second trace and then find the point of intersection. So if you did the point of intersection, you move the cursor to where you think, you move it to where you think it is the point of intersection, and basically hit enter 3 times. And it says 0.999994, and then 1.00012. That's the same as 1, 1. I mean, that's the close thing. That's very close to the 1, 1. Again, the other way, if you look at the table, look at 1, 1. If you notice that on the blue line, it's not a line, but the blue quadratic function and the red, they both have 1, 1 in common. So you can see that 1, 1 is the point of intersection, and there's only one point of intersection for this problem.